we finished the first chapter. I think we revised the redox part again, and then we had
Yes,
started the second.
we
We had
yes, ma'am, we
started the
started
second chapter.
the second.
Fine. So tell me, beta, any problem now in the redox part? I hope that would be clear now.
Yes, ma'am.
Fine. So have you practiced like taking out the oxidation number and things like that? Although that's very basic, but have you practiced that somewhat?
Yes, ma'am.
Fine. So coming back to our NCRT for the second chapter, today, Neha, what we'll do is that we'll quickly revise some of the topics from the second, like the second chapter, okay? And then we'll actually go on practicing some questions, okay, based on those topics. Fine. So I
Okay.
would want it to be like very quick. If there's any problem in between, please do ask me in detail. We'll obviously discuss that in detail, but hopefully we'll be able to complete some of the topics today. Yes. Neha, could you please remind me as to what topic did we finish in the last turn?
Ma'am, we
We
already
finished the
finished the introduction. Only the first page. We have to start from here.
I think we would have finished the indicators by then.
Yes, ma'am.
So everything would have been discussed about the indicators, right? I discussed the synthetic ones, that is the man-made ones and the natural ones. Yes,
Yes,
the
ma'am.
pH, all of that fine, that has been discussed. Basically, we have to now begin with the chemical properties of the acids and the bases. I think we would have also discussed some of the physical properties of the acids and the bases. I'm recalling that some of that has been discussed, right?
Yes, ma'am.
Fine. So basically, main with the acids and the bases. This has been done. This has been done. Hmm. Yes. So basically, how do acids and bases react with metals? We will quickly discuss this. This equation, this reaction is generally regarding the dilute acids. Okay. So let's take HCl in the dilute form. Okay. And then we'll add any metal. Let's say sodium is the metal here. Okay. What the reaction will be like? The reaction, I will represent the metal using M, not in specific metal. Okay. What the reaction would be? The reaction would take place as this. Salt of the metal will be formed. Yes. Plus hydrogen gas would be released. Correct? That is the general reaction for the between dilute acids and metals. Yes, so any problem here?
No, ma'am.
Fine. Now the second important point here is that it will be in the aqueous state. The acids will behave as acids when they are in the aqueous state. Therefore, when we are having this reaction, acids has to be in the aqueous form. Then only the H plus would be released. Yes, it would be like dissociated into the ionic form H plus Cl minus, and here H plus would be released, therefore making it as an acid. When this H plus would be released, this would actually bond with the metal, therefore forming the salt. Yes or no, bachcho? Any confusion here?
No,
We'll
ma'am.
quickly take one example. Let's say, beta, we have Amir. Are you there in the class? Okay,
Oh, yes, ma'am.
fine. So let's take the example of a dilute sulfuric acid. Okay, assume that it's the dilute sulfuric acid in the aqueous form, and zinc is like zinc is the metal. What will be the product here?
Zinc sulfate plus hydrogen gas.
Zinc sulfate plus hydrogen gas. Okay. And now you should be very well aware of how to make the chemical formulas. Okay. Zinc with a valency of +2. Fine. So that is all done. Now some of the important points regarding this activity. Okay. Basically, what do you observe on the surface of the zinc granules? Imagine that we have a zinc as the metal. Okay. We take zinc granules and we react this with any acid. Let's say we have dilute HCl. Why do we see the bubbles near the zinc granules? What bubbles are that of? That is of the
Hydrogen gas.
H2 gas. Yeah. Basically, those H2 gas is nothing but in the bubble form near the zinc granules. Fine. Second, why are the bubbles formed in the soap solution? Because these are, see, in the reaction, what is happening here? In this activity, what is happening here? Whatever reaction is taking place here, okay, the products of this reaction are transferred here to the soap solution. Now we know that the hydrogen gas bubbles has been formed, therefore the hydrogen gas bubbles would be transferred onto the soap solution. That is why we see bubbles on the soap solution. I hope that is clear. Any confusion in this?
No, ma'am.
Ahmed, respond. Okay,
Yes.
fine. Now, how do we test that what gas has been produced? What is the name of this test? First of all, it's the pop sound test. Yes. We
Yes,
will
ma'am.
bring any source of heat energy, any lighted matchstick, any lighter, whatever we have, and when we'll keep that here near these bubbles, okay, what we will see? We will see basically the gas would burn with a pop sound. Okay, that would confirm that what gas is present here, that is hydrogen gas. Okay, any confusion here?
No, ma'am.
No, ma'am.
Neha? Fine. So that has been done. Now, basically, the metal in the above reaction displaces the hydrogen atoms from the acid as hydrogen gas and forms a compound called as a salt. Fine. So this has been done. Now, this is again an example of a displacement reaction. Yes, bacho? Displacement reaction. Actually, tell me what will happen if there is an acetic acid. What will happen with HCl? HCl we have already discussed. What will happen with HNO3? We have already discussed. What will happen with CH3COOH? That is acetic acid. Yes, बच्चों. Hello.
Yes,
Hello.
Yes,
yes,
ma'am.
ma'am.
Yeah, both of you first of all turn the cameras on, बच्चों. Please. Yes. Now let me know what will happen if we have this acetic acid instead of the HCl acid or the sulfuric acid. What will happen then? But this is also an acid, although that's a weak acid, that's a different thing, okay? But it will also produce the same thing, that is salt of the metal, okay, plus hydrogen gas. Is it clear? Now, what is the difference between a weak acid and a strong acid? I'm not talking about the concentration here. I'm talking about the weak acid or the strong acid. What is the basic difference here?
It will produce less amount of hydrogen ions when dissolved. And if it's a weak acid, and but if it's strong acid, it will produce more number of hydrogen.
Yeah, that's fine. Basically, what will happen, the strong acid will completely dissociate into water. Like whenever it's dissolved in water, it will completely dissociate into the ionic form. Whereas a weak acid will not completely dissociate. Some molecules will still be left to dissociate, while some of the molecules will be dissociated. Are you getting it? Assume we have 10 molecules of each acid, that is HCl, and that is acetic acid. Okay. When we dissolve 10 molecules of HCl and water, all 10 molecules of HCl will completely dissociate into H plus and Cl minus. Is that okay? Whereas when we dissociate the CH3COOH, that is the acetic acid and water, 10 molecules of that acid and water, let's assume only 5 of them will actually dissociate into the positive and the negative ions, rest will not dissociate. That is why we say that acetic acid is the weak acid, whereas HCl is a strong acid. I hope that concept is clear.
Yes.
Okay,
Yes,
fine. Coming on to the next point. What will happen when a base reacts with a salt, with a metal? Mhm.
Salt plus hydrogen.
Salt plus hydrogen gas. Okay. Now here this reaction is not possible with almost every metal, and if it is, it's a very complicated reaction. Okay. Now one important point that I want to discuss here: if this is the salt beta, this is the salt. Okay. Sodium zincate is the salt. Yeah, fine. Now, can you tell me, we know that in a salt, we have two components. One is of the cation and other is of the anion, right? This is what comprises of a salt. Yes, Bachu?
Yes, ma'am.
In this case, that is sodium zincate. Which one is the positive one and which one is the negative one? Can you tell me that? So Na here, Bachu, is the positive part, right? Which has been coming from the NOH. See, this Na is coming here, right? Are you getting it? Na plus OH minus, this would have been dissociated into this. Are you getting it, Bachu?
Yes, ma'am.
And this zincate is the negative part. Okay, there's a question we will be discussing after this part, that what is the positive and the negative part when a metal reacts with a base. So the metal and the oxygen form the negative part of the salt, whereas Na from the base, okay, alkali forms the positive part. Is it clear? Amir, please respond.
Yes, ma'am. It's clear.
Fine. So coming on to the next part. Yes, metal carbonates and metal hydrogen carbonates. What is the difference between them? Metal carbonates are, right? What are metal hydrogen carbonates, right? What is the common name for this? Let's say we have a sodium hydrogen carbonate. What will be the common name for this?
Bicarbonate.
Yeah, that will be like metal bicarbonate. What else will be the name of this? Sodium or baking soda? Washing soda or the baking soda, बच्चों? Metal bicarbonate is called as the baking soda or the washing soda. Hmm.
Baking soda.
Yes. And sodium carbonates are referred to as the. Is it clear? Please be mindful. Yes. So sodium. Acha, what is the reaction between them? Between sodium carbonate, let's say we are taking sodium carbonate plus acid. What will be the reaction between them? General reaction. Always salt of the metal, okay, plus carbon dioxide, very important, a characteristic part of this reaction along with the formation of water. Yes, see, okay, okay. And similarly, we
Yes.
will have for the sodium bicarbonate, the same products will be formed. Now, how do we test that whether carbon dioxide gas has been released in this reaction or not? How we will test that?
By passing
We will
it through light water.
Exactly, very good. So we will pass this carbon dioxide gas through the lime water, that is also calcium hydroxide or slake lime in common words. And if carbon dioxide has been produced, the product that will be formed will be calcium carbonate. Okay, that will be there in a white precipitated form. Okay, along with the formation of water. Fine. Now, this is very important. What is the name of this test? Hmm. Lime water test. Okay. That is the test for carbon dioxide. See, the test for carbon dioxide is the lime water test, whereas the test for the hydrogen gas is the
Pop sound
So,
test.
pop sound test, right? Fine. Now, once we have calcium carbonate, okay, if we pass excess carbon dioxide through this, what will happen? What will happen? Calcium
Cal-
bicarbonate would be formed. Okay. Earlier it was the calcium carbonate. Now the calcium bicarbonate would be formed. Any problem here, बच्चों?
no, ma'am.
No, ma'am.
Limestone, chalk, and marble are different forms of calcium carbonate, already discussed. All metal carbonates and hydrogen carbonates react with acids to give the corresponding salt. Corresponding salt simply means the negative ion of that, the carbonates and the metal carbonates and the metal hydrogen carbonates, okay, and the positive of the metals. So carbon dioxide and water. How do acids and bases react with each other? What is the name of this reaction?
Neutralization reaction.
Neutralization reaction. Amir, I have a question for you. What type of reaction is the neutralization reaction, beta?
The one in which acids and bases combine together to
Yeah,
form salt plus water.
yeah, that's right. That you have defined what is neutralization reaction, and that is 100% right. My question is that we have learned some types of chemical reactions in the first chapter, right? On that basis, what type of chemical reaction is this neutralization reaction? I will write the example here. Example HCS, aqueous, very obvious, NOH, aqueous. Give the salt, yes, bachcho. NaCl plus H2O. What type of chemical reaction is this, beta?
Double displacement.
Excellent. It's a double displacement reaction. Excellent. Right. Base plus acid will give us salt plus water. Okay. In similar to this, we can have, see, metallic oxides. What is the nature of the metallic oxide? What is the chemical nature of the
Basic.
metallic oxide?
Basic.
Basic. Excellent. So whenever this is also reacting with an acid, that will also be the same reaction, giving you salt plus water. Okay. Again, a form of a neutralization reaction. If we have non-metallic oxides, what will be the other reactant? That will be the base. And then also we will have the same reaction. Is it clear? Because the nature of the non-metallic oxides is acidic. Fine. Name the color, note the color of this. What has happened to the copper oxide? Yes, what will happen to that? If we have copper oxide in a beaker and we have added dilute HCl. Just a second. Yeah. What will happen to this, Bachu? We have added dilute HCl to the copper oxide in a beaker. What will be the salt that will be formed here?
Copper chloride.
DuCl.
CuCl. What will be the formula of that? Tell me in which valence state is copper here? +1, +2. Just looking at the formula.
+1.
+1. Neha?
+2, ma'am.
+2. See, Amit, it is CuO, right? That means copper is bonded to one oxygen, which is -2. Therefore, copper here is in the +2 state. Okay. Therefore, when copper is in the +2 state, how we will get the formula? Copper and chlorine +2 and -1. We will get it as CuCl2. Is it okay? That is the salt that will be formed. So please be mindful of these things. The blue-green color of the solution is due to the formation of the copper 2 chloride. See, copper 2 chloride. 2 is representing the oxidation number here, the oxidation state of copper that copper is presenting. Okay. Right. So note the color beta, that is very important. The blue-green color. Okay. What's the color of this salt? The question could be asked in this manner. What's the color of the copper chloride salt? That is blue-green in color. Fine. Any problem here? Should we move ahead?
Yes, ma'am.
So non-metallic oxides and the basic, that will also be same. Yes. Non-metallic oxide and a base. Can you quickly give me one example here? Hmm. See, they have given a good example. Calcium hydroxide is a base, right? If we react it with this thing, carbon dioxide. What is carbon dioxide? Non-metallic base. I mean, this non-metallic oxide. Yes, it's a non-metallic oxide. Therefore, it will be acidic in nature. What will be formed here? Acho, what will be formed here?
Calcium carbonate plus H2O.
Excellent. Calcium carbonate plus H2. Any problem here?
No,
Fine. Yes. Quickly coming to these questions. Why should curd and sour substances not be kept in brass and copper vessels? Yes, because these are acidic. Okay. These are acidic and they will react with the copper. See, brass is also what? Zinc and copper. Yes. So they will react with the metals and they will form the salts which could be toxic to the human health. Okay. Secondly, which gas is usually liberated when an acid reacts with a metal? That is a hydrogen gas. You will do that yourself. Metal compound A reacts with dilute hydrochloric acid to produce effervescence. What do you mean by effervescence, bacho?
Is it the smoke taste?
Okay, okay, I get your point. Neha, what is effervescence, beta?
ma'am, is it the bubbles produced during
Yeah,
the reaction?
yeah, exactly. Yeah, whenever the bubbles are produced, okay, that is effervescence. So whenever we actually pour in the cold drink on the glass, okay, in the glasses, what do we see? We see that effervescence happening. Wherever there is carbon dioxide, we will see effervescence. I hope that is clear. Okay. So effervescence is again a physical display that carbon dioxide is present. Metal compound A reacts with a dilute hydrochloric acid to produce effervescence. The gas evolved extinguishes a burning candle, right? A balance. What will be the very good, important? If the compound formed is calcium chloride, what will be the equation here? Can you tell me? So something is written. Metal compound A plus dilute hydrochloric acid giving you carbon dioxide plus calcium chloride. Yes. What will be the name of this compound, Bacho?
Calcium oxide.
Calcium oxide. Okay. Hmm. Neha?
Ma'am, I don't.
Huh?
Ma'am, I don't know. I'm not able to.
You know it. At least try it. Neha, do not give up like
Calcium
this.
oxide.
Why do people think that it's calcium oxide? Can you explain that to me, bachcho? No worries, explain it. Mm-hmm. Explain it, bachcho, explain it. Amir, say that point, beta.
Because on the right hand side, calcium is reacting with chlorine.
Mm-hmm. Fine. Neha, what is your explanation to this, beta?
Ma'am, because when calcium oxide and HCl like react together, it gives like the reactants, like it gives the products, corresponding
Fine. Yes,
products. That's
fine. Bachcho, see. I'll write it here. Please try to focus. Okay, bachcho. See. Let's say, bachcho, if you are saying calcium oxide, okay? You people said calcium oxide, right? If we are reacting with a dilute HCl that we already know is the second reactant here. Do you agree with this point? The dilute HCl is the second reactant here. Okay. We have to find the first reactant. Both of you agree with this part?
yes,
Yes,
ma'am.
Fine. So basically, if you just keep the reactants, leave the products, okay? Just keep the reactants in your mind. This is a simple reaction between a metallic oxide and an acid, okay? And that will surely give you the salt plus water. But so we have discussed it right now. Yes. Are you getting it? If you just take
Yes,
these as the reactants, by simple reaction that we know that this is a neutralization reaction and therefore salt and water will be produced. Now CaCl2 is definitely a salt, but in any way, is carbon dioxide being produced in this reaction between between a metallic oxide and an acid, bachcho? Yes or no? Amir? Yes or no, Amir? No. Then what is the problem here? See, we have already understood. I will explain you here. Pay attention. We have one reactant that is HCl. Okay, that is HCl. Other reactant is to be known. Okay, what is the product have actually given to us? CaCl2, that is the salt plus carbon dioxide. Okay, plus carbon dioxide. Now see, A plus HCl. Can I say that this is something, the A has to be something related to the metal carbonate or the metal bicarbonate? Yes or no? Metal carbonate or the metal bicarbonate, then only when that compound is reacting with the this thing and acid with a dilute acid, then only the salt and the carbon dioxide gas will be produced. Do we both agree with this?
yes, ma'am.
Amir?
ma'am.
Amir beta, why is your camera not turned on?
Ma'am, it doesn't work. Even if I switch it on, it won't show my video.
Okay, fine. So therefore this is nothing, A compound is nothing but it's a, and what is the metal here? How do we get to know the metal? Metal is calcium, right? Through the salt you can get to know the metal is
Calcium carbonate.
calcium. Yeah, so either the compound is calcium carbonate or the compound is calcium bicarbonate, that is CaHCO3. Is it clear to both of you, bachcho?
Yes, ma'am.
Fine. And what will be the balanced equation? What will be the balanced equation here? Can you write it? Try to write it quickly. Try to write it, both of you. I will ask you both of you. Acha, if we take metal carbonate, I mean this calcium carbonate, or if we take calcium bicarbonate, will the equations be different? Will the equations be different or will they be the same?
They'll be different.
They'll be different. Try it. Both of you try it. Okay. Quickly. Amir, are you doing it?
Yes, ma'am.
Fine. Good. Done? So somewhat like this, you would have got the equations. Instead of sodium, we'll just have calcium. Yes, that's the only difference. Yes,
Yes,
bachcho.
ma'am.
Do
Yes.
not
Yeah.
forget to write H2O in the balance equation, because this we know is the general equation for this. So although it's not mentioned in the question, but you need to write it. Okay, then only you will have the correct equation. Fine. So this has been cleared. What will be the formula for calcium carbonate? What will be the formula for calcium carbonate, bachcho? Ca
CaCO3.
Yes, you.
CaCO3. What will be the formula for this calcium, this thing, CaHCO3? I've already spoken the formula. No, it's fine. So I basically the question is any other problem in this? I hope you have understood this question, how to approach such question.
Yes, ma'am.
Yes, ma'am.
So please just do not rush in and say that calcium oxide would be the like any reactant. Just try to understand the reactants first. Basically, you should at this level you should actually know all the reactions that you are having and what will be the reaction given. Just the reactants you can just seeing the reactants you can tell the reaction. Okay. So just figure out the reactants and based on that you can tell the reaction which is taking place. Is that okay?
Yes.
So what do all acids and bases have in common? What is it that they have in common? See, the simple point here is that they have the ionic part, and whenever they will be dissolved in water, they will get dissociated into the positive and the negative ions. Okay. And these positive and the negative ions basically are they will conduct electricity because they are small charges and they act as a charge carriers. Yes. Let's say we have H plus, we have OH minus. Yes. These will act as the charge carriers, and therefore they will conduct electricity. And that is the basic point here that they are trying to tell you that only when they are dissolved in the water, they will act as the acids and the bases. Okay. Now, what are the strong acids, weak acids? I've already discussed here, but quickly some examples. See, can you quickly tell me some examples of strong acids?
It's here.
Mm-hmm. H2SO4.
Sulfuric.
Yeah, good. Nitric acid. Weak acid, quickly, bachcho.
Acetic acid.
Mm-hmm. Acetic acid. See, all the organic acids they are generally weak acids. Okay. All the
Lactic
organic
acid.
acids. Yeah, all the organic acids, good. Acha, what is the difference between the mineral and the organic acid, bachcho?
Mineral acids are strong acids, right? Organic acids are weak.
Beta, not always they're strong acids. We always use the term mostly because carbonic acid is not a very strong acid. Hmm.
Okay.
That is a mineral acid. Yes. Yep. See, the point is very simple. Mineral acids are those acids which have been derived from the minerals. They are the inorganic acids. That the inorganic acids do not have the carbon component in them as such. Okay. Is it clear? Therefore, they are the inorganic acids. Now, the
Okay.
organic acids are derived from the organic species, that is the plants and the dead body. Basically, the plants. Okay, remaining the remains of the dead plants and animals. You can say from that also we can have the organic acids. Basically, from the organic matter, the acids are derived from the organic matter. Okay, they have the carbon component in it. Okay, they are generally the weaker acids, not always. Again, yes, Amar, you were saying something, Beta.
Yes, ma'am. I'll have to leave a little early today. Zafar.
Okay, but
At like
it's why?
7:50. Ma'am, I have to go out somewhere for an emergency.
Okay, fine. At what time you have to leave? Tell me in how much time do you have to leave? Can you tell me that?
Like 15 minutes.
15 minutes.
Yes, ma'am.
So basically, your class gets over at 8. You need to leave at 7:50, right? 10 minutes early.
Yes, ma'am.
Fine, fine. You can do that. So that's it. Coming on to
You,
the
ma'am.
next part. This has been done. Acha, always remember this point is very important. We will never write H plus because it cannot exist like this in the water. Okay. Either we will say H plus aqueous or we will say H3O plus. Okay. Is it okay? So be mindful of these things. These are very important things. Bases which are soluble in water are called as
Alkali.
Alkaline.
alkali. Quickly, an example of an alkali:
Sodium hydroxide.
sodium hydroxide, potassium hydroxide, calcium hydroxide. But
OH.
magnesium, yeah, sorry,
NaOH.
yes, that is sodium hydroxide. Good. But magnesium hydroxide is not a very strong base. Okay, so be mindful of magnesium hydroxide. What's the common name for magnesium hydroxide? Milk of
Magnesia.
magnesium. Okay, mostly it was used as an antacid. So these are the type of questions that could be asked. Okay, the chemical formula for milk of magnesium, that is nothing but magnesium hydroxide. Acha, what about the pH of the salt, bacho? What about the pH of the salt? If we have a strong
Neutral.
acid and see, no, listen, we have three conditions. Okay, we have three conditions. First, bacho, if we have a strong acid or strong base, okay, and in this case only if we have a weak acid and a weak base, in this case the salt will be neutral. The salt will be neutral. Clear? Like NaCl. So Na from the strong base, that is sodium hydroxide, and Cl from the strong acid, that is HCl. So both of them being strong acids and a strong base give rise to a neutral salt. Okay. Now the second case is if we have a strong acid and a weak base. Okay. If we have a strong acid and a weak base, okay, bacho, this will be slightly acidic. The pH of this salt will be slightly acidic. Why? Because the acid here is strong. Third, we have a weak acid but a strong base. In this case, what will be the pH, right, bacho? The pH will
It
be
will
towards,
be
yeah, towards
Basic.
slightly towards basic. Fine. So that is the simple point here. Okay. Any confusion in this?
no, ma'am.
No, ma'am.
Okay, fine. Is this a base? Is this a base, bacho? We have discussed this while we were discussing the chapter. Yes. Is this a base NH3 or is this an acid? Mm-hmm. Yes, bacho. NH3 is a weak base, bacho. Okay. It will dissolve in water to form the ammonium hydroxide, clear, which is a base. We have discussed this, bacho. So, okay. Quickly, one example of a weak acid. Although we have discussed all of this, so nothing to discuss in this one. What do we mean by the mono acid and the mono base, beta? Mono acid and the yes. Hmm.
Are there
Basically, it's the wrong term that
acids?
I'm. Just a second. It's monobasic and dibasic. Yes. Monobasic and dibasic. Yes, bacho. Yes, Amir, you were saying something, beta. Mm-hmm. Say.
Is it
It's like
about like
having
See, beta, these are acids. First of all, these are acids. Okay. Acids are either would be the monobasic, dibasic, bibasic, whatever it is. Okay. Basically, it simply means how many OH minus ions can they replace. Okay. Example, HCl is a monobasic. Okay. It's an acid, but it's a monobasic acid. Okay. If I say H2SO4, it will become a dibasic. I hope the point would be clear. Okay.
yes.
Neha? Fine. Okay, but so we have discussed already all of this. So adding water to acid, acid to water. I hope that is clear. Should I revise that? No. Should we move ahead? So what is the point? Basically, acid should be added to water drop by drop. Okay, that is the correct method of adding. If water is added to acid, it will be a very exothermic reaction that will eventually lead to the injuries. What is dilution? In dilution, what is happening?
We are decreasing the concentration of that particular acid or base.
Yes, we are decreasing the. What will happen to the pH if we are diluting any compound? The pH will increase or decrease?
Increase.
The pH will increase. Fine. Already discussed all of these questions. Any problem? Quickly go through these. Quickly. Any problem in any of these? Hmm. Quickly, bachcho. Any problem in these?
no, ma'am.
No.
pH. Any problem in the pH part, bachcho? So it is from 0 to 14. Okay. 7 is the neutral one. Okay. pH simply measures the concentration of the H plus ions. Simply measures the concentration of the H plus ions or the hydronium ions. Okay. If we are moving towards the basic pH, that means the concentration of H plus ions is decreasing while the concentration of OH minus ions is increasing. It will not mean that the H plus ions are not there. It's just that OH minus ions are in much greater quantity than that of the H plus ions. Okay, that is a simple concept here. The lesser the pH value, the more acidic the compound is. The more the pH value, okay, the less acidic the compound is. I hope that would be clear.
Yes.
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 And what is the indicator that what is the indicator which is used to indicate the colors against different values of the pH scale? What is that indicator that is used to do that? The
Universal.
very good, the universal indicator. So towards very acidic, it will be 0 and 1. So what will be the color? That would be from red. Okay. As we move towards the basic values, it will change to the blue part, and in between, that is the neutral part, we have something that is the green color. Clear? Yes. Now, quickly, bachcho, we have discussed already all of this. Any confusion? Do you know the values of all of these? What is the pH value of the saliva? Is it acidic or is it basic?
It's slightly acidic.
What is the value? What will happen after we eat a meal? Will the pH value increase or will it decrease? Amit,
Will it
I'm not able to understand you. Beta, say that
will it
clearly.
decrease, ma'am?
But whenever we will have any meal, okay, the pH value in our saliva will decrease. Okay, it will decrease. Why? Basically, the concentration of H plus ions will increase because of the breakdown of the food by the microbes in our this thing mouth. Okay, and saliva basically that will increase the pH value. I mean, sorry, that will increase the H plus ions concentration, therefore decreasing the pH value. Is it clear? And that is not a very good thing for the enamel. Therefore, it is advised to clean the mouth after eating so that the pH of the saliva is maintained. Okay. What is it that the enamel is made of? What is the name of the compound? Hmm. What is the name of the compound that enamel is made of, Bacho? Calcium
Phosphate.
phosphate. Basically, a crystalline form of the calcium phosphate. Okay. So yes, Bacho,
Okay, ma'am.
tell me, do you have the values, pH values for all of this? Yes or no? Should I give you any problem? Please ask me. Like any part here which you do not know the pH value of, please ask me that.
Ma'am, can you give the pH values of these
All of them?
solutions? Yes, ma'am, because I'm not
Okay. Okay, fine. Quickly write it. Saliva before meal, around 6.2, right around 6.5, okay? The mid value, okay? After meal, less than 5.5, okay? After meal, less than 5.5. And that is when the enamel will start corroding. So the question would be asked at what pH the enamel would start corroding. That is below the pH of 5.5, okay? Third one,
Okay.
lemon juice, 2.2. Lemon juice around 2.2, okay? Quite acidic. What is the
Yes.
acid present in the lemon juice, bacho? Citric acid? Yes,
Citric
that
acid.
is a
Yes.
that's again an organic acid. And we can also have ascorbic acid. Ascorbic acid is nothing but vitamin C. Okay, ascorbic. Clear? Fine. Colorless aerated drinks. What do we have in the aerated drinks? Do we have carbon dioxide? Yes or no?
Yes,
Yes.
ma'am.
And that will form the carbonic acid. So basically, the pH would be around 3 to 4. Okay, the pH would be around 3 to 4. Carrot juice. Between 6 to 7, but write 6.2. For a specific part, write 6.2. Slightly, basically, the point is it's slightly acidic, okay? Because other juices, like apple juice, that is more acidic than the carrot juice.
Okay.
Fine. Yeah. Coffee. Is that acidic? Hmm. Is coffee acidic or is it basic?
Acidic.
Acidic. Good. So between 4.8 to 5.2 or 5.1. Okay. That's the pH value of the coffee.
What acid does it?
There are many different types of the acid, malic acid, different acids, many acids. Okay. Basically, it will also change the pH value of the coffee will also change depending on the type of the coffee that you're using. So it's a very complicated part. Okay.
Okay.
Fine. What else is left with tomato juice? Yes, that will be acidic or basic?
Acid.
Acid. What is the acid present in the tomato? That is the
Tartaric acid.
oxalic acid.
Okay, sorry.
Tartaric acid is present in the tamarinds. Okay. So tomato basically has oxalic. It also had some amount of the citric and all of that, but you can just write oxalic acid. Okay. Yes. Tap water, will that be acidic or basic? Yes, Sachin.
Base.
Good. So around 7.5 to 8, that will be the value. One molar NaOH. This M represents molar here, okay? 1 molar NaOH, 1 molar HCl, okay? So this is 14 and this is 1. Very ideal values, okay, bache? Very ideal. 0 to 1 basically, but they're like very ideal values. Not really possible as such. Okay. Clear? Any confusion here, both of you?
No, ma'am.
Fine. I wanted to discuss that. What is the name of the acid which is present when the ant or the bee stings or something like that? When the ant bites or the bee stings, what is that acid? That is
Methanoic acid.
Methanoic
methanoic acid.
acid.
What's the common name for that? Formic acid. Formic acid. Okay.
Yeah, ma'am.
If you want to write it down, please write it down. I think I've already told you the formula. HCOOH. Formic acid.
Ma'am, what
Uh,
is the formula?
HCOOH. This one.
Okay.
um,
Okay.
ma'am, can I
When
leave now?
yeah, but you can leave. Thank you.
Thank you, ma'am.
Yes, Neha. When is the rain called as acid rain? When the pH is below 5.5. Okay. When the
Okay.
pH is below 5.5, then only it is acid. What is the compound that makes the rain acidic?
Sulfuric acid, then nitric acid.
Good. Sulfuric acid and the nitric acid. Okay, less than 5.6. Be specific with the NCRT, that is 5.6. Okay. What is the pH of the blood? Mm-hmm.
Ma'am, I kind of forgot the pH.
Is written here 7.4. Okay. But
Okay.
these diagrams are very important. I've already mentioned all of these while we were discussing the lecture, but at least these parts which are already mentioned here in the NCRT book, okay, the pH of these compounds become very important here. So I hope that
Yes.
would be clear to you. Milk of magnesia, again, nothing but Mg magnesium hydroxide here. What juice is present in the gastric juice? What acid is present in the gastric juice, bacho?
Hepsin.
Is that the dilute form?
Yes.
Dilute form? Huh? You will see for it, okay? Fine. So yes, what is the pH of the soil in your backyard? Basically, what is the pH of the soil? Can we have just one pH for every soil? No. Basically, it will depending on the plants that we are having. Okay. So for a range, we can say 6 to 7.5. Okay, 6 to 7.5. Yeah. Now there's a question I think in NCRT or somewhere else that says why does the farmer add calcium oxide, calcium hydroxide, and calcium carbonate? Yes. Why would these compounds be added? What would be the purpose of these compounds being added to the soil?
To decrease the acidity of the soil.
To decrease the
Acidity of the soil.
yes, exactly. To decrease the acidity of the soil, to maintain the pH of the soil, that is fine. Okay. And this calcium carbonate specifically will act more of a buffer. Okay. Buffer, you understand? Basically, in simple words, any compound which will not suddenly change the pH of anything that it is being added to. Okay. Slowly and with the need that will arise, the pH will be changed. Okay, that is what we mean by a buffer in simple. Yeah. So don't go into much detail, but just to increase the alkalinity. Fine. pH of the digestive system has been discussed. Okay. The tooth decay, we have already discussed this. Any problem here?
No, ma'am.
Once it's below 5.5, the degradation will start. Okay. That has been discussed. Yes. So bee sting leaves an acid which causes pain and irritation. That acid is nothing but the methanoic acid. That is the formic acid. Okay. Methanoic acid is the chemical name. Okay. Formic acid is the common name. Okay. And we can have a mild base here like a baking soda, basically, which will give the relief. Why can't we use washing soda here? Why are we using baking soda? Yes, Neha.
Is it because washing soda is slightly like more acidic than baking soda?
More acidic.
Like
Washing
slightly.
soda, is it more acidic? Washing
It's
soda,
not,
will that be more acidic, or
it's
baking
not
soda, will that?
acidic, but it's not acidic, but the pH might be lower than baking soda. Is that the
No.
reason?
The point is the pH is actually stronger than that of baking soda. Basically, it is stronger base, and we just cannot use a stronger base as like this on the skin. Okay, that is the point. Therefore, whenever you would see things like that, we would always prefer baking soda rather than a washing soda. I hope that would clear your concept. Yeah.
Yes.
Now, nettle leaves, basically, again, they will have their stings, and we will have methanoic acid in them. Now, again, important point here, traditional remedy is rubbing the area with the leaf of the dog plant. Basically, what does the dog plant do? It is basic. Okay, so it will neutralize the effect of the methanoic acid. Okay, therefore, both of them are grown side by side to each other in the nature. Okay, so see, this has been discussed. Vinegar, acetic acid. What's the chemical name for acetic acid? Ethanoic acid. Ethanoic acid. Okay.
Okay.
Orange, citric acid, tamarind, tartaric acid, tomato, oxalic acid, sour milk, that is curd, lactic acid, lemon, and skin, and methanoic acid. Fine. Yes. Question 1, quickly go through question number 2.
Solution A has more hydrogen ion concentration than solution B, and A is more acidic. A is acidic and B is basic.
So the third question, we have already discussed this. Fourth question, bache, I just now discussed this. Okay. So quickly go through it. If there's any confusion, we'll discuss it.
No, ma'am, no problem.
Yes, the salt part is left. Okay. Now, what I would suggest to you, go through the salt part yourself. Okay. Now, if there's any confusion in that, you can obviously ask. Fine. Or you would want me to revise it, I will revise it for you, whatever you want.
Ma'am, I will revise it, and if I have any doubts, I'll just ask you on the
Fine.
next.
So then only we'll discuss the questions, okay? Because once you have discussed, once you have finished the chapter, we'll discuss the questions on the next one. Is that okay with you?
Yes, ma'am.
Fine. Then as of now, I'm stopping the class, okay? Because then we have almost discussed everything. In the next class, we'll cover the questions, and then we'll cover any doubt that you will. Fine.
Fine.
When is your exam?